Hello everyone. The time has come to start with the first session of the afternoon. So I will ask you to sit down and take your seats. So we talked in the morning about the new versions of the SDMX standard. And this afternoon we talk about VTL, the validation and transformation language. Angelo Linardi from Banca d'Italia will chair the session and will show us a bit what has been going on in this space, what implementations have been attempted or succeeded, and what kind of issues are still open for the community working around VTL. So I'm not going to take more of Angelo's time. I give it to you then.
Thank you, Luca, and welcome everybody to this hopefully exciting session on VTL. I hope that you had your coffee because VTL is not that simple, I know. And I introduce myself. My name is Angelo Linardi. I've been working in the IT department of Banca d'Italia for 30 years. I'm pretty old. And always working on statistics applications. Since 2021, I'm a member of the technical working group, replacing Vincenzo Del Vecchio, who was my boss and then retired. And now I'm coordinating the VTL task force since then. So, where are we now is a beautiful song by a very famous. Starting this new, let's say, improvement of the VTL, this was really the question that we have been asking in all the VTL group. And so, where are now? I start with the famous Gartner hype cycle of technology. This is more or less the very famous hype. And applying this to VTL. Well, everything started in 2013, where VTL task force was formed by the SDMX Secretariat. Or really, we are talking about history. Pre-history, in 2008, Banca d'Italia, we are in production with the VTL predecessors, which is expression language in production. So since 2008, we have a live production using grandfather of VTL. Then in 2015, the first version was being published, and in 2027, the 1.1 version with all the bug fixing and so on. And finally, the language was more or less complete, consolidated in 2018 until 2020, when the grammar then was adjusted and fixed. And so the language was there. Everything was there, but the long and difficult theoretical work has been done. But it was just at the moment some very side part of the SDMX community. And from then, just changes to VTL for 3.0. That was the time in which Vincenzo retired, and so I took the responsibility of the VTL task force. And then we decided really to stick on the implementation. So the very good theoretical work can be done, the mathematical foundation has been done, the information model was defined and consolidated, but now it's time to have some tools, some engines that really put this wonderful theory in practice. And so we gather all the 4 institutions that we knew that had the VTL engine in production or just in the implementation phase, and started asking what do you want? What are the needs of the user that you know? And for them, for that point, we started the new version, which is recently published at the end of September 2.1. And afterwards, I will give some information about it. But really focusing on the implementation, focusing of... we know that there are a lot of barriers in entering VTL because it's difficult, because but it has a lot of power in it. We can testify it since 2008 we have this language in the collection and production process. And so now, especially in the last 2 years, we started having some consultancy, some proof of concept, some pilot projects with other institutions, and all the presentation will give some information about these pilot projects that have then been done in a lot of agencies. And we strive to go into a large adoption of the VTL. And I don't know who is, I didn't voluntarily want to have a slide on who knows VTL and so on. We know that it's, it's something that is really not very well known, but we think that the good thing is to learn it is just using it. And that's why we are really going to have all these initiatives with all the institutions that want to adopt it in the next future. Well, some words on VTL 2.0. Obviously, there were some bugs in the 2.0 version that we fixed. Coming from the needs of the users, we introduced some new operators. The time operators were missing completely or almost completely. So, and also some operators that are the random one, which is in the every programming language. So we introduced it also in the VTL. And then we adjusted some existing operators just to go into the direction of making mind easier and more nearer to the needs of the users. And these are the list of the changes. Not very much, but the big change is the one that we are going to finalize, hopefully, by the end of this year. So the VTL documentation is made by 3 components, the user manual, the reference manual, and the grammar, the Backnau's form grammar, G4, for the parsing. And they are PDF, and it's very difficult to read them. And obviously, there are some inconsistencies between the 2 manuals and between the manuals and the grammar. So what we started some months ago, and we are going to publish, at the end of the year, the new documentation, which is in markup languages. So we have all the power of links and between all the manuals and so on. First of all, obviously, to improve readability and reduce the inconsistency between the grammar, between the user and the reference manual. Then, to make people aware of what an operator, how an operators behave, and which is the input structure, the output structure, and so on, we have several examples, and more will be added in the next future. So, for each operator, we give the input and the output structure, and we give also a CSV for the data. So you can really see which is the behavior of the operator. So in order also to have a test-driven of the engines that are in, just the 4 of them, and if someone wants to implement other ones. And so it's much easier to see what the operator does in terms of real structures and data. And then, obviously, we are adding all the examples that the implementer have done during the years. So the number of operators now in of examples in the manual is very few. They are very few, and we are adding them in order just to have more topological coverage. It's impossible to have a complete topological coverage of the language, but we have to improve this. And last but not least, the grammar will be semi-automatically derived by the examples in order to avoid inconsistencies. So really, having the grammar taken from the behavior of the examples, it's much easier to test and to avoid divergences between the manual and the grammar. I call Attilio here just to have a short look of the new documentation. This is just a pilot. I will present Attilio later, which is a colleague of Banca d'Italia.
Hello. This is just a preview. Actually, we did not publish the new documentation yet on the official site, but because it's still under review, and there are some refinements that we are doing, but for the most part we are almost there. The technical working group already saw some of these examples, I mean some snapshots at least, and this is on a repository of mine. I will start from the end actually. I will show you the output, okay? So the new documentation format is of two types. We have HTML and PDF. This was one of the requirements. It is completely developed using markup, using Sphinx, some Jinja scripts to work and create dynamic templates in case it's needed. Even because we wanted to create a level of interaction between the documentation and the engine developers. So we decided to make a special work on the examples that Angelo mentioned, and I will show you how. Let's have a look at, for a start, at how the documentation is done. Here you have the index. This is the user manual. All these design choices, let's say, from a technology and format point of view, were decided in a work stream that was created in the task force, in the VTL task force. As you can see here, this is the, if you ever had the chance to have a look at the PDF manuals of VTL, you will recognize most of the formats. As you can see here, we have also the class diagrams. These class diagrams are created using a markup language as well. We selected the plant UML as the underlying technology. All that you see here is created using source files, source code that is in a GitHub repository, and then it is packed and processed in a CI/CD style, let's say, by GitHub Actions. So let's have a look at the more complex diagram, like this, for example. And I will show you the source code. It's just a bunch of lines of code. All this choice, of course, as you can imagine, improves the traceability of the changes to the documentation and also improves the work. At least it makes the work of the documenters easier, because they can check exactly the places where they have to do the changes and what changes have been done during time. Let me show you a bit of the reference manual. Of course, the technology is the same. Here we have a particular section of the reference manual that is represented by the operators. Every operator, the operators are divided into families, the Boolean operators, string operators, and so on and so forth. And for example, in the string operators, we have all the operators that work with strings. Let's select one. And the format of each operator is more or less the same for all of them. So you have the syntax, some information, inputs, results. As you can imagine, it is done. And then also we have a section that is represented by the examples. So we have a set of examples for each operator. And these examples, as I said, are not templates, they are technical files. I will show them in a moment. We have, for example, this is the first example. We have the input of the transformation, the inputs of the transformation. We have the transformation, it is here, and we have the results. The inputs are CSV files. The transformation is a simple text file, .vtl. And if you want, there are some, let's say, hints that suggest what are the roles of these components. In this case, this is an identifier. In this case, this is a measure, so that you don't necessarily need to go to the structure. But if you want to go to the structure, you have a link here that takes you to the actual structure of this input data set. This JSON structure here is aligned to a format for structures that we agreed in the task force. Since VTL does not prescribe any format for inputs and outputs, it is at a higher level. Nevertheless, in the task force, the implementers felt the necessity of having at least something that could be, let's say, helpful to harmonize the part related to ingesting and outputting data. So we decided this very simple, very light way to define the structure. We are not talking about SDMX, of course. VTL is much simpler from a model point of view. So this is not part of the standard. It is just a technical guideline. Who wants to use it is free to do it. I go to the source, and as you can see here, we have the reference manual and the user manual. As you can see, these are the templates that Sphinx processes in a specific GitHub action. So anytime any source file is updated, immediately it is the HTML and the PDF are updated as well. Let's check the model, for example, where the diagrams were stored. This is a table. This is a preview. The actual code is this one. This is the table, as you can see. And let me check where is a diagram. Okay, and this is a diagram. As you can see here, start UML. These are the directives that state the position, the contents of each box of the class diagram. So even in this case, even this picture, what you see as a picture in the output, is traceable, because if you change a single line of code, the picture will be updated, but you also see what is the change that provoked that update. Going to the reference manual. Okay. For example, what was it? The string. Okay. The string operators. Let's see, string concatenation. There is a directory for each family and a directory for each operator, and in each operator you have the contents, that is the preface, let's say, that you saw in the operator, but most of all you have the examples. And as I said, the examples are very technical files, so CSV files, JSON files, and a VTL, and one or more VTL transformations. Let me show you. This is a very plain CSV file. And this is the JSON that I showed you before, because it's then linked to the example. And the transformation is here. Yeah. Very simple. Now, what's the good part of this? This is something I'm particularly proud of, actually, because while revamping the documentation, we found some errors in the examples, lots of errors in the examples. It can happen. I mean, it can happen because there was a misunderstanding between the task force and the one who made the example. It can happen because the specifications have changed and the example was not. It can be. Now, with this, since these are very easy files to be processed automatically, we can set up a process from the engine, starting from the engines, that uses these files as a test suite. So the engines can easily create processes that get these files and run the examples as if they were a test suite. So to a certain extent, this becomes a small compatibility suite with respect to the specifications. Of course, even from the engine point of view, it's a benefit because the engines can always check their adherence to the examples in a very easy way. Of course, this is also a driver to increase the number of examples because VTL, of course, is a language, so every operator has many use cases that are possible, and in the various use cases, there are things that can happen, things that cannot, and there can be many questions regarding the small use cases that are related to a single operator. So the more examples are there in the manual, and the more clear VTL is in its behavior. And doing it this way ensures also that these things, even if the example grow bigger, they can be managed in an easier way because you always can give a run to all the examples by the engine and make sure that even if you have 1,000 examples, they are correct. Thanks.
Okay, thank you. Thank you, Attilio. And, well, we have finished, so without wasting time, just we go to the presentations. And there will be a Q&A session at the end. But if there is time, some question can also be accepted after each presentation. Thank you so much. I invite Antonio and Javier, who the first presentation. They already been presented today, so please, the floor is yours.
Hello again. And well, I'm very pleased and proud and happy to be here introducing this presentation because it is actually the result of a lot of work that we have been doing during the last 6 years. So it is this new VTL engine that is, well, we just opened it and published it last week, right? But it is the result of 6 years' work. I'm just going to do an introduction to give a bit of context because the main presentation is going to do by Javier, who has been leading the development very successfully, I have to say. But I wanted to provide you a bit the idea of why we are here, what is that we have. So 6 years ago, we started developing what we call the VTL suite. And for this, we had an idea in mind, which we can summarize as VTL as a product, right? So what we want to have is something that any organization that is interested in using VTL can use the suite and worry only about writing VTL, right? That's the idea of a product, no? That you something that you are going to start using and you just care about what you want to care, not ops things or other related things that in the end someone has to take care, right? But hopefully it is not the organizations, okay? So we always had clear from the very beginning that if we wanted to support this, we had to act in two different fronts. On the one hand, we have to support business users. This is critical because one of the nice features and the core ideas behind the VTL is that it's for business users, right? We want business users to be able to write the validations and transformations, share them, understand them, and maintain them, right? This is the critical part of VTL. So we have to support them well. For this, we have a web application that we call VTL Playground that provides the UI, some user management, workflows, and so on and so forth, everything you need to work well with VTL. But we cannot forget the automated pipelines. I mean, especially in the case of validations, but in any case, I have known the cases of having the very last date 10,000 files, receiving 10,000 files, right, that you have to validate. If you are in production, you have to make sure that you process all these files and everything in place, right? So you need to have a system that is able to do that, right? And integrate with the rest of the systems that you have in your organizations, okay? So we have what we call the VTL manager that is providing a REST API and a queue management system that is allowing you to do exactly that, right? So that the VTL is a component that you plug in your system, okay? But of course, behind the scenes, behind the VTL playground and behind the VTL manager, we are using a VTL engine, right? This is the VTL interpreter. You get as input some data set and some VTL, and you get as output the result of applying this VTL to this input, right? This, we started 6 years ago. We have been using it for a long time now, but we decided to open it some time ago. This is when Javier proposed, let's do a refactor, because we started it a long time ago, so we completely refactored it, and last week we just opened it and published it in GitHub. Of course, we want integration with SDMX. One of the nice features as well of VTL is that it talks very easily with SDMX, right? So behind the scenes, this is not completely accurate today. It will be in 1 month or so, right? Because we are using our legacy library, SDMX Tone, at the moment, right? But certainly when we will have the version 1.0 of PySDMX, it will be updated so that we use PySDMX, okay? So in this picture, what we have here is the PySDMX and VTL engine. PySDMX shared, right? But it is SDMX Tone was already open source. It is our contribution to the community, right? We want to make this open source software that it is usable by anyone. I hope we will have lots of users and questions, requests, and everything. And we will have the VTL playground and the VTL manager as our value-added components. Okay? So we just wanted to give you a bit of context, because now what Javier is going to present is the new open source VTL engine.
Thank you, Antonio. Good afternoon, everyone. So I'm going to start with some overview. First of all, the VTL engine is a full implementation of VTL 2.0 language, as it is the current version that we are getting for the public release of the VTL 2.1 announcement. And once we have the full package, we'll get it to the latest version and to keep it up to date. Secondly, we perform an exhaustive semantic analysis, because our approach that we are making is that you don't need the actual data in order to ensure that a code is valid or a code meets your need. So what we do is, what I will explain later, is to validate absolutely everything without the need of adding any data points to the process. Just using the data structures, validating the data types, using the operators inside the VTL script, and so on and so forth. We made a decision which may seem controversial dealing with data, especially dealing with large data, which is to make it single-thread execution. And this comes for several reasons. One of them is to ensure that operationally it will be easier to install and easier to use on any machine. So to help the people in the organization, the IT people in the organizations, to ensure that they can install it in every environment that they may like, as long as, of course, they have a single processor, which have been with us since the 80s. So yeah, that would be the use case. And on our side, we wanted also to make the behavior to be predictable, in terms that when scaling the data that we are using the same VTL script, then the behavior will be predictable with the resources that we currently have in our server. So that's why we have, as of today, the single-thread execution. We based it on two widely used data science libraries that are called Pandas and DatDB. These two libraries are used by several projects, big data projects, organizations throughout the world, and now we are getting it into the VTL language also. The choice of these libraries will be just for compatibility with any format that you may like, using the Pandas API for it, and also DatDB in terms of performance with several operators, like the aggregation operators, the joins, whatever. We would like to state that it is currently used in production. Of course, not at the refactor, but before the refactor, it is currently used in production. We kept the same functionalities, we kept the same tests, we kept absolutely the same experience when using the VTL engine. We just simplify the API, improve it, and improve the internal maintainability of the code. So we can still state that it is used in production by several organizations, so they can, so you can trust that the system is working fine and currently being used. But also you can trust that the VTL engine will work because it has a 90% of code coverage with 2,800 unit tests, including the 200 tests that appear in the reference manual as examples, but also more than 2,000 tests that we have been adding over the years based on use cases that we have been taking from our client, based on our own use cases that we have been developing and we have been trying. So yeah. You can trust that it will work with almost any use case that you may think of, and if not, you can always give us a pull request so we can collaborate with each other. How does this work? Well, the VTL language is complex. That has been stated today a couple of times. But we need to start first of all with the VTL script. We need to perform a syntax validation. We interpreted the grammar and we generate what is called an AST for it. And later on, we find if there are errors or no errors on the syntax. Later on, we perform a direct acyclic graph, which means that in order to avoid any kind of cycles inside the script, we ensure that the script will be run properly, and there will be no infinite loops or anything like that using this VTL script. Continuing with it, we perform the semantic validation. As you can see, now we have the VTL script, and we have now the data structure also. With the data structure, we have the information of each data set that we are using and how to include them in our VTL script to generate the proposed data structures. What are the validations that we are making? That the graph is performing okay, the data type validation, the compatibility with the operators that has been used, and the calculation of the derived data structures that comes from the VTL script to ensure that the user will have the exact result that is meant to do with the VTL script in a simple way. Finally, the interpreter. The interpreter is where, once we have the input data structure and the computed data structures, we add the data. Okay, so this what we will consider as a version, as a final version of the script with the data structures, and then we want to test it with some data to see that we can generate the process. So, for example, in this VTL script, when we get the rounding, the data set D, then we'll round it to, for example, to integer values, just 100, 150, whatever, to perform the operations actually on the data. Later on, we keep only the measure that we want, in this case, var 1, and then we generate data set B. Finally, we perform another filtering to filter this measure that it is remaining for us to have the number, to have the values that are greater than 10. So then we'll generate the data set A. This could be considered as final, so then we can ensure that the result is working fine and that the VTL script meets our needs. Of course, if we want to make an open source library, we need to make it easy for the users. So we redesigned the API completely. That's one of the main things that we wanted to do, the refactor, in order to make it easy for the users. Just 5 lines of code, you will be able to perform a semantic validation of the VTL script, just by adding, for example, everything that we may need to validate it, and the result will be, as said, the computed data set without any kind of data points, just to ensure that the structure is working properly. Okay? Regarding the execution, we need to ensure that we have just the same examples, but we do also add the data points. Okay? The data points, we may add them by plain CSV files, we may add them also by SDMX data, formatted files, SDMixation, SDMX CSV, or SDMXML, once we integrate by SDMX into the VTL engine. But we may also use it to integrate the 3 buckets, which are some tools that they are being used by data scientists and as a data warehouse, so you can just download the files from whatever you need, and later on validate them and execute them using the VTL language. We find it as a nice addition. Also, we ensure that we are efficient in memory, meaning as we are generating a graph, we may find the opportunity to be more efficient in memory by not loading all the data sets at once and not loading every data point at once, just by loading them whenever we find it necessary, and whenever we find that data set is no longer used, to remove it from memory. For that, you will need to specify also an output folder, which means where do I want to have my data completely stored? That's it. Later on, we remove it from memory and we ensure that the execution is continuing with the rest of the data set. Of course, if you are concerned about compatibility, as I have said, Pandas has a lot of reading API methods. If you are thinking about any kind of data science format, like Apache Parquet, Tableau, these kind of things, it will be also supported by Pandas. So we find it that it will be very compatible with any format that you may like. And we designed the API thinking about also a data science use. To ensure that the VTL language is also used by, for example, statisticians, or for example, people that want just to make simple transformations inside the data, we need to give them the tools that they need and the tools that they are used to. With these kinds of API and this kind of design, we ensure that we can provide them this kind of behavior. Finally, semantic analysis and the run can be executed completely dependently, meaning that you can validate your data without any kind of data points. And of course, if you have your VTL script completely final, then you can execute a bunch of data files, as we have seen in the use case of the VTL manager. You can execute in any time that you would like, as the process is completely dependent from one to each other, and you just convert and gather your use cases as many times as you would like. What about the performance? Well, performance is a topic that is quite interesting for many people. As you will say, okay, but I want to make this on any machine, or maybe I want to run it in my laptop. Any statisticians who want to just not to be dependent of a setup with a lot of servers or anything, a big environment that requires to call the IT team to say, okay, I need this to be set up and whatever. We try to make it in a way so anyone can use it, even in your browser, if you're using some techniques or using some WebAssembly techniques. And also it can be included in a web application. So for the semantic analysis, we included it in our VTL playground. As it is a web application and it is used by the user, we found that a nice use case will be just to be analyzed in your VTL script, to be just writing it, adding the data structure you may need, the library items you may need, and ensure that you are generating a complete script, whatever you may find. Of course, if we are generating large script, we need to ensure that it is performance. So we found that on the largest script that we have, which has 183 VTL transformations, we can validate it in less than 2 seconds only. In fact, this may be even improved by a lot, because the generation from the VTL expression to what it is called the AST, that is performed by the Antler library, takes around the 99% of this process. So if you are able to catch the AST in a web application, which we'll use in the VTL Playground suite, in the VTL Playground application, then you will find that it takes no longer than a few milliseconds just to validate the whole VTL script and to ensure that the user has a nice user experience when generating his own VTL script. On the running, on the execution of the data points, we ensured that we were able to execute it with small and medium data files. These are the majority of use cases that we have been finding in all of our clients and in all of the production stages that we have been finding. Also, it would be better for better maintainability, but we acknowledge also that operationally you need to schedule some or to allocate some resources to your machines and whatever, so you need to get predictability. That's why we are making it on single thread execution. Okay? But some use cases also needs large files, and they need to perform, for example, aggregation on large files. So as of today, as long as they fit in memory and you could use, for example, big machines like the one provided by the cloud, then it will be just easier in order to get as many resources as you would like. As long as the data set fit in memory, then you will be able to execute them. You can slice, for example, the data points that you have been using, and later on start increasing the size of the data files in order to ensure that and you will find that it has a linear progression, so it will be quite better to see, okay, so I can execute with this VTL script this amount of data on each data set that I want to make, so it's quite predictable. Finally, single-thread execution. We ensure that the cost-effective data pipelines will be used. So the cloud and for example, if you would like to get it on every single machine, and you would like to only have like a proof of concept in an organization, then it has to be cost-effective. If not, you can find it like this guy that left his EC2 instance on, and later on he's living now in the street. So. Please remember to, whenever you try to design a software tool, to ensure that anyone can use it without, I don't know, maybe selling himself to someone else. You know? Finally, on the next steps, we are getting the VTL 2.1 version that will be soon. Also, the SDMX VTL artifacts in terms of the SDMX mapping to the VTL artifacts that are defined in the information model. And of course, we will get the parallel execution for those use cases that we are finding that may need support for very large files and also out-of-memory files. Of course, on this, we need to include some Spark research and development, but also some other libraries that we find that may have a similar performance and also a similar, much better maintainability rather than Apache Spark, because it comes with several, as on our opinion, it comes with several operational risks, like, for example, setting up a Spark cluster in production inside an environment. So we'll try to make it sure that if we need to use a Spark, then we'll use a Spark. If not, we'll try to find any kind of library used by data scientists, which there should be a lot of them, to ensure this parallel execution and also to this big data execution using VTL. And that's it. Thank you so much for your time. I hope.
Thank you so much, Antonio and Javier. We are a little bit behind our schedule, so for time constraints, I invite Attilio to come here. Let me introduce you. Also, if I know you very well, anyway. Attilio is an advisor at the IT support unit of the Economics and Statistics Department in Banca d'Italia since 2010. He is responsible for development of software tools and libraries. Together with other colleagues, he supports data scientists and researchers using technology for managing and analyzing data. He's a member of SDMX Technical Working Group and the VTL Task Force, and the coordinator on SDMX Connectors and VTL Engine and Editor open source initiative in the Banca d'Italia, which is presenting now. Thank you.
Thank you. Thank you, Angelo. I was very happy to see the previous presentation, actually, Antonio, because I think we are on the same page on many things. And this one. Okay, sorry. And especially for the fact that VTL, being a language for statistical processing, should be particularly aimed at business users, and VTL tools should be designed with business users in mind all the time. Actually, I completely agree with you to this regard. When we started coding this VTL engine that we have done, it was back in 2018, and probably VTL 2.0 had just been released. And the situation was not completely clear regarding VTL, because the tools available, it was not easy to understand which tools were available at the time, what kind of support of VTL they had, if it was 1.1, 1.0, the new 2.0. And I was coordinating at the time the task force, a task force in the statistics committee of the ESCB on shared SDMX tools. So we were asked also to include VTL in this analysis, let's say, and we decided, being that the situation, to develop our own engine. We took the opportunity of having some time for this task force, and we said, okay, we have to learn VTL. No one of the task force knew it, actually. And the best way to do it is to try and develop an engine. And also this way we could feedback good information to the task force that is creating the specifications, because as Matt said, you are not sure that the specifications are correct until you try to implement them. And when you try, you find lots of problems that you have to go back and correct. So we started, and the first thing that we wanted was something that was user-centric, actually, because we didn't know VTL, but we knew the expression language that has been mentioned by Angelo. That is a very similar language that is in our statistical data warehouse at the Bank of Italy since many years ago. And we knew that though it is very powerful, very useful, users don't love it so much, in particular economists, statisticians, because the environment where you have to work is, of course, it's not R, it's not Python, and this can be a problem for them. So we said, okay, let's try and make something that can be as comfortable as working in RStudio or working with Python. And we ended up with a project. It was not funded. It was we had no plans, so it was sort of cowboy coding actually at the time, but very free. And we wanted to do something that was user-oriented, but also very flexible, as to be used even in production context. So there's a big difference when you have to model a VTL transformation as a statistician, and you have to understand what data you have, how you want to transform it, check the output, get back, and so on. And when you have to use this transformation in production, I mean, the drivers and the needs are completely different. We wanted to anyway take the two sides of the problem together if it was possible. So we ended up with this project, with this software. Also, one thing that we wanted to do is to give the possibility to users to connect their transformations to the most popular types of data that they could have, because VTL does not say anything about that. I mean, the VTL specifications do not prescribe nor suggest any way to treat input data. It's out of the scope, nor to store data. The VTL is a theoretical, but when you go to implementations, this can be a problem, because too much choices usually create a problem to human being. So what we think we have produced in these years is something that is very easy to install for users. It works in a laptop because it is our preferred, let's say, delivery method is an R package. It's not the only way to use it because it's very componentized. I'll show you in some moments, but you can install it as easily as you install an R package in R. So unfortunately we could not upload the R package to CRAN because we have lots of jar files, and CRAN has a maximum dimension for the package to be uploaded. So it's just, you have to install it directly from GitHub if you want. Then we have, as I said, for flexibility, the main implementation is completely Java, but we have different components, and one of those is an R front end, included, of course, in the package. So we have a seamless integration with R. So you can mix R functions and commands and code with VTL code. You can start with R, then run VTL transformations, get the results, continue with R. It's very useful, according to us, because it's a way users work with our warehouse. They, for example, load the data from strange places, they pre-transform the data, they clean it, etc. Then they take something from the warehouse or fire some transformations to the warehouse with the new data, they get back the results, they continue maybe updating a database or creating a report or a chart or whatever. So we wanted to also to be able to, let's say, implement this kind of use cases. And also in R, we developed, using Shiny, the VTL Studio. We took inspiration from RStudio for the VTL Studio. It's an integrated development environment where you have all what we think is useful for coding VTL transformation. So you have, of course, the console, but you have full control of your data sources, of your metadata repositories. You see the input, you see the output, you see the structure of the input, you see the structure of the output, as if you were in a normal data analysis tool. What did we get from these years of development? As I told you, we understood, the main outcome is that we learned VTL, at least. This is, for this I can be quite sure. The other thing is that we learned VTL in a very practical way. We made our own opinion of how VTL should be, the difference between how it was and how it is becoming, and we fed all these considerations into the task force discussions in these years, and according to us at least, it is getting VTL better, in particular because it is getting more usable in the real life. We had the possibility, having an engine, to test immediately the changes that we wanted to do to the model, to the operators. We were able to understand the consequences from a user point of view, from the business case point of view. Also, in this period in which VTL is being evaluated in many places, we had a tool that showed VTL in action, not convincing users necessarily. We don't want to convince anyone, but surely we want to demystify the fear that VTL is a complex language. This is something that has been applied to SDMX for a long time. Now, luckily, it's not. You don't hear it any longer. Maybe because Edgardo gets very angry when someone says SDMX is complex. Probably also because the tools that have been implemented make it easy to use, and this is also what comes out from good VTL tools. Users understand that it is yet another language that they just have to learn a bit, but not much different from the other ones. Last but not least, as I showed you before, we have a test runner for the documentation. The documentation and the engine were designed in order to work together, and this is a benefit for both sides of the problem. Now, Angelo, please, when it's 5 minutes to you just 5 minutes, great. Now, this is the basic architecture of our engine. In the middle layer, as you can see, we have the pure Java part. We have the actual VTL specifications implementation. So we have the compiler. Of course, the compiler does everything. Syntax checking, matching with the structures, and all this that is needed for actually compiling a VTL rule. Then we have the executor. The default executor is in memory. Recently, we also added an Apache Spark executor because Spark is very fashionable, so we decided that we wanted it too. We are still experimenting, but the nice thing is that depending on how you write the transformation and where your data resides, the two engines can work together, actually. Of course, the Spark executor is not mandatory. If you don't have a local Spark or a remote Spark to connect, the engine works just in memory. Then we have the upper layer, that is the interface to user. As I said, we have this RVTL package, that is our preferred way to use it today, that also contain the VTL Studio. We have a very simple VTL kernel for working in the Jupyter notebook, so just firing a transformation, getting back the structure of the results. We also had a web API, a REST API, but we decided to deprecate it because we think that a REST API for VTL engines is a very important feature to have. So we decided to stop the development of that and wait until in the task force we define a standard API for the engines, either if it's in the specifications or as a technical guideline, no problem. But we wanted to start exactly aligned to the harmonized way of working, and then we have a very simple CLI interface, command line interface for who wants to just fire commands from a prompt. The interesting part, according to me, is also how we handled this data and metadata processing, because as I said, VTL does not prescribe anything. So we create this concept of environment for data and repository for metadata. So you have these places where data resides, and the environments are able to take the data in the form where it is, on the disk or in the internet, and shape it as the VTL engine expects it to be, so according to the VTL model. Today we have, of course, the Scratch environment is the place in memory where the output of transformation goes. We have the R environment, so we are able to read data frame directly from the R global environment in case you are working in R. We have the SDMX environment that previously was based on the SDMX connectors, but since we have a roadmap of further integration with the Fusion Metadata Registry, now we switch to the SDMX core library. We have a CSV environment, a very simple environment that lets you put CSV files in some directories that you specify. Spark environment, of course, if you have Spark enabled. And you have the possibility to create your own environment. Say you have a database with your data, shaped in a way, you create a JDBC connection to the database, you shape it as VTL wants, and according to the interface, you can plug your environment. Same for metadata, we have the SDMX repository always connecting to SDMX web services, and we test again against the Fusion Metadata Registry, but it could be any SDMX 2.1 compliant metadata call, structural metadata. We have the JSON repository, very recent, that works according to the guidelines that we have created in the VTL task force. So this very lightweight representation of the VTL data model in JSON. Last, what are we going to do in the future? Well, of course, we are going to align to the specification, to the new version of the specifications, and we are actually already building the documentation environment for running the examples in the new documentation. We are joining the SDMX.io initiative. It was a long journey for us at the Banca of Italy, but now we are able to do it. I'm very happy about that, and I have to thank the BIS colleagues for the patience in these months. It was a formal, great achievement for us. We are working on a revamp of the VTL engine documentation because it was, we had focused on code and not so much on documentation. I don't know if it's a pattern in IT. And as I said, we will work on the REST API, both on the implementation side and in the discussions in the VTL task force. Also, there could be a Python front-end that works as DR1. Probably it's not longer necessary, since I saw just the presentation from Antonio. Probably it's something that is redundant at this point. And what we are thinking about is a special packaging of the engine for education. So something that already contains the transformations that are in the examples of the documentation, so that users already have out of the box the engine, the data sources, and the transformations, and they can see immediately run an example, change it, look at the results of the transformation, stuff like that. That could be very useful because it would be like a live documentation. And that's all for me. Thanks.
Thank you, Attilio, especially for time. And now I'm introducing the next presentation, will be by Glenn. No need of present Glenn. And from Nicola, I'm just introducing Nicola. Nicola worked for more than 10 years at INSEE, the French Statistical Institute, developing IT open source solution for metadata management. He has been interested in VTL since 2018, developing several products and actually participating in the evolution of the language. He joined the Making Sense company almost 2 years ago, contributing his open source contribution, providing all support, expertise, and development around metadata and standards. Glenn and Nicola, the floor is yours. Thank you.
Thank you. Yes, so for me, I mean, one of the really nice features of VTL is its flexibility. I mean, as we've seen already, it can be used in a whole range of contexts. But obviously, sort of one of the key contexts, and probably the one most interest to this workshop, is about the context of you using it in SDMX. And I think things we've already seen, probably in the last couple of presentations, there's sort of SDMX sort of integration sort of happening in most of these projects. But what Nicola and I will report on today is one of those efforts to integrate VTL using the Travas and the FMR engines. The Travas execution engine and FMR. So I'm going to just sort of recap sort of very, very briefly on that within sort of the SDMX and the FMR context, and then I'm going to hand over to Nicola for arguably probably the more interesting bit of the presentation, which is about the practical execution and how this actually works with Travas. So just a little bit of a recap. So VTL obviously has its own information model, as we know, it's based upon GSIM, but there is some, and actually some quite detailed explanation about how VTL and SDMX work together in the SDMX technical guidance, the SDMX technical notes. I mean, several pages of this. But I think in the work that we've been doing, really there are two sort of practical elements that come out of all of that for a sort of real practical implementation. And one of those is how VTL programs can be stored and exchanged together with SDMX structures of the data set involved. And this is, or the key use case, or one of the key use cases for this is perhaps in data collection, data reporting, where it would be really nice to be able to share perhaps with data reporters not only the SDMX structures of the data sets that they're being asked to report, but also the VTL as well for content validation and for business rules. So not only can reporters structurally validate their data before submission, but by also shipping the VTL and also giving them the opportunity to execute that on reporting data before it's actually submitted means that the quality of that data is so much higher. Not only is it structurally valid, but it can also be validated from a business rule perspective as well. And as we know, this has a lot of efficiency benefits from the point of view of reducing that correction cycle, which is sort of so expensive for both reporters and collectors. So key use case for that. But the second key element here is, I think about how the artifacts, how SDMX artifacts can be referenced in VTL code. So there has to be a way of obviously using or referencing the VTL artifacts in the SDMX artifacts as you write them in VTL code. So the technical specifications sort of speak a lot about that, but we'll have a look at that just in a minute. But again, focusing first about the storage and exchange of VTL. So in the SDMX information model, it actually has quite a number of structures which are added around about, I think, 2020. So they've been in the information model for some time. And really haven't had a lot of love. quite a few structures here, but I think probably the takeaway, if you haven't seen this really before or haven't sort of looked at it in any detail, is they all centre on the transformation scheme. So the transformation scheme is the sort of the centre of the universe for STMX structures in VTL programs represented as STMX structures. And probably the simplest way, or the way I think about it as well, is that a transformation scheme is effectively a VTL program. So if you're thinking about how do we actually sort of encapsulate a VTL program in the STMX structural metadata world, well, it's effectively the transformation scheme. And there's a bunch of other structures that go around that. I won't go into all of those, but probably the one to highlight here, I think is the rule set scheme. So the rule set scheme is where the validations, the validation rule sets are stored, and they can be referenced in as transformations in the transformation scheme. And in a way this is really nice, because obviously it means we've got a way to encapsulate a complete VTL program to the extent of a bunch of VTL code which actually does something useful. So maybe a bunch of validations, on the data set. So that's what we have. It's in there already. It's been in there for some time. Now actually starting to be used. But the other element, though, as I mentioned, is this feature of being able to reference STMX artifacts in VTL statements and rules. So effectively, of course, when you're writing VTL, you need to be able to now, in some way, reference the artifacts that you're actually working with. And in fact, the specification says you can reference it using a URN, which is really useful, because obviously the artifacts can be uniquely identified by a URN, and there are a number of ways to do that. You can reference it using a complete URN, as we can sort of see from that top example, which is very explicit, but also quite verbose. There's quite a lot of typing involved there. But you can also actually use partial URNs as well. So chopping off some of the not so sort of relevant information. So the the data point rule set example below there, as you can see there is a reference to an STMX CL area code list. We've cut off all the other information about the URN. But this is okay, because of course we can infer that is actually referring to a code list from the context of the VTL. The fact it's referring to a value domain tells us that actually, even though we don't explicitly say CL area is a code list, we can infer that from the context of the URL. And the third way is by mapping schemes. So it provides this way of actually creating an alias for individual artifacts. So the example at the bottom there is we've potentially created an alias for exchange rates for the EXR data flow. So another way of doing it. But anyway, the takeaway here is that the STMX specification for VTL provides for directly referencing STMX artifacts within the VTL code. So when you're writing VTL code, this is what the specification says you can do with that. So what does this mean in practice? So if you're a user of FMR, or if you've seen it perhaps in the global registry, you will know that VTL has appeared in the structure menu for quite some time, and probably a few have sort of looked at it and gone, that's very interesting, and then closed it. So, but anyway, it's now actually sort of becoming useful. So for probably at least the past 3 years, VTL FMR has supported all of the VTL structures, so you can create the structures, maintain the structures, exchange the structures, serialize them in the normal way. What we have added recently to that is some more features to make that that more useful, and one of those is actually VTL code syntax checking on structure submission. So previously you could create a transformation scheme, put absolutely anything you felt like in the VTL code, and it would store that as such. But now what it will do is it will syntax check the VTL code. So on submission of a transformation scheme for storage in FMR, you can be confident that if that is accepted for storage, the code, the VTL code that you put in there is at least syntactically correct. It doesn't go so far as we're seeing as semantic checking, which is very much a domain of the engines, but it will check that it is syntactically valid. So FMR, again, as you may know, has basic authoring and maintenance web UI for creating these structures. It is very basic. It's okay obviously for creation and sort of odd maintenance of it as well, but obviously it also supports, as usual, the SDMX structure maintenance API. So that then opens the door for some very much nicer tools. So tools from meaningful data, other tools as well that we will see. So FMR does not aim to be a fully featured VTL IDE. No, there are some better tools for that, and those two tools can integrate via the normal SDMX structure API. So one of the other things that's added, which is actually really quite important for practical implementation of VTL and SDMX, is a feature that at least we've called deep structure cross-referencing, and this relates back to what I was mentioning earlier about the ability to reference SDMX artifacts within VTL code. Now, if you do that, you are creating effectively a cross-reference between that transformation scheme and the structures that you're referencing. So if you're creating a transformation scheme that references a data flow that you want to use as an input data flow, perhaps as part of some validation, it's very useful for FMR to understand that you have actually referenced that. Why is this important? Well, because it means when a VTL engine wants to execute your VTL program, remember a VTL program in the SDMX world is a transformation scheme, it can simply query, use the structural metadata API to query for that transformation scheme, specifying references as descendants. And in one message, the engine will retrieve not only the transformation scheme with the VTL program, if you like, but all of the structures it references. So all the structures that are both referenced explicitly through the SDMX artifacts, but all of those structures that have been referenced actually by URN or by partial URN within the VTL code. So this is very much an efficiency thing. It makes it very easy for a VTL execution engine to get not only the VTL program, but also all of the relevant structures. The alternative is basically to try and suck down all of the metadata within the registry, and you can do that. But obviously, organisations sometimes have quite large metadata sets, and that's quite inefficient. So this is a very efficient way of the VTL execution engine be able to get not only the program but also the relevant structural metadata that you reference. And lastly, it's really helpful because it enforces metadata referential integrity, which is a very important element of any registry, a very important element within FMR. What do I mean by that? Is that what you don't want to do is reference an artifact within your VTL code, and then someone comes along and deletes that artifact. So if you're referencing perhaps a code list within a rule set, FMR now enforces that referential integrity such that if someone tries to delete that code list to do something which would break that referential integrity, FMR will prevent that. So it ensures, again, proper referential integrity, not only with explicit references, but also with implicit references, which are these references by URN within the VTL code. So this is the deep structure cross-referencing. So there's a sort of a conceptual example of a transformation there, very simple transformation. A data flow referenced by partial URN, ECB EXR, resulting in a new data set. So the process there is what FMR will actually handle. So as I said, the syntactic analysis of the code will check that this is syntactically valid, which is really helpful again for quality and consistency purposes. It'll identify that the EXR is indeed actually a partial URN, so it does some syntax analysis to work that out. As you mentioned earlier, it can infer, even though it's not explicitly told in the URN that this is a data flow, it can infer that by understanding the context of the VTL code. Within VTL, this can only be a data flow. It'll verify the existence, and then only after it's worked out the cross-references will it store the transformation scheme. So before I hand over to Nicolas, just very briefly, what does all this mean in practice? Well, this is fundamentally how it sort of works actually in practice. FMR is effectively a passive participant in the execution process. It provides the metadata and access to repository for the VTL program. The actual heavy lifting is all done by the execution engine, which consumes the input data sets. Pulls, as we said, can now execute a single structure query of FMR to get not only the VTL program, but also the structural metadata, which is referencing that, execute the VTL it's received, and then produce the output data sets. So that's all I want to see now. So I'm going to hand over to Nicolas to show us actually something more interesting, which is the actual execution engine.
Sorry, Nicholas, but Glenn took almost all the time. Anyway, please.
Thank you. Thank you.
Can we switch? Okay, thank you. It's better. Okay. So just quick words about Traverse, so the VTL engine, which is a Java VTL engine with Apache Spark including in the main way to run Traverse actually. So it enables you to have local session or distributed session. All the tools we build are open source, and we don't provide kind of software, but small PCs as modular PCs, and you can choose to use one or another, or your choice. So I call that a galaxy because Traverse is the main engine, and around Traverse we have some application using Traverse embedded, so a Jupyter Notebook, a lab, an API, batch. All these use cases are directly available on Docker Hub. We don't handle only Java to perform VTL calculation. We also have TypeScript engine, so enable you to run directly VTL in your browser. And we also have an editor, which is a React component you can include easily in your app. So it's directly on NPM. A few new things about VTL 2.1. We update tools. I can just show you the editor. So that the new can change the color easily, but you have a random case and new time operators which are implemented. Traverse has been updated too with so the random and the case operator which are implemented, no time operators for now, and you have on the website a blog with main news on the development on Travis. Same for Travis TypeScript, which has been released this morning, including the new VTL version, and supporting also random and case for now. Travis Jupyter is a special client of Travis Java. It's just a new kernel with VTL inside, so we'll see after that. And all the first tools I show you, as I said, are open source, but we also build custom solution for clients. As I said, we can make a mix with species, and I will show you a desktop application we built for a customer, which is a CESD, to show you a new module in Travis, which is a lineage module. I've kept the documentation because it's not just parsing the VTL script, it's leveraging with building metadata, lineage metadata. So we produce RDF, and in few lines in your Java, you are able to push in a RDF triple store, or just having a file with a string JSON LD, provide it with your IPA, and display bubbles in your UI. So I'll just show you quickly. If I take this one, so that's the editor which is integrated in this client app. And if my script is valid, I can display the provenance information. So I have a program with step, and each step called data frame. Then we also have variable included with the link, which are really extract from ontologies, RDF ontologies. So this one is prov and SDTH, which will be released soon by the DTI Alliance. Regarding the link between VTL and SDMX, so we developed a use case, quite a simple use case, which comes from Mince. So we have two data sources as input. We made some validation, some cleaning, some aggregation, and at the end, we merge sources to compute a new indicator. So that's the detail. And we display directly in Travis a new module, which is VTL SDMX. You find documentation on the website. I think there is also a blog article for that. And the documentation with all the function we provide. And just to show you, we'll go to the Jupyter. And I have an onboarding example. Another thing which is open source, you can just consume the image we deploy on Docker Hub, and you take the link of this repository to have an initial configuration. So Docker run, access to that, and you can see that you have Python, but also a VTL kernel, which is with the Travis under the hood. We have a different sample. The first one is the Unse use case, and as you can see, we provide really different methods. The first one enabled to load an empty source just to check metadata. So it's the demo effect. Instead of having just the result, I have all my logs, so it's not really comfortable. Okay, that's it. So I have loaded a data set with the SDMX message information as empty for a preview mode. I can do the same, giving the SDMX metadata and the location of the data source, and I can load my source. I will don't do because of log issue. You can also run your SDMX pipeline directly as preview mode, so with empty data, just reading the SDMX message and having the shape of each data set you build through your process. The last interesting function is this one, which is a run, and you define where is the GSD, the data source, and you can also persist the persistent data set defined in your VTL transformation scheme. So I will not activate because of demo issue, but it works. Next step, we collaborate for months sometimes to exchange, to how empower the link between VTL and SDMX. And we start a collaboration with BIS, so to try to refine, to tune the VTL experience if needed. Maybe you are already at the top. For making sense, it's important because our VTL SDMX connector is a new one, so we don't support every shape we can receive. So we have to work with new use cases to improve the plugin. And this collaboration will be with UNSD, and that's a way for them to poke the integration of VTL in the process. So you can discuss with Abdullah if needed. I'm in time.
Thank you very much, Nicolas, for shrinking everything. And without wasting on time, I'm inviting the ISTAT colleagues. Dario Camol is a senior analyst programmer at the Italian National Institute of Statistics. He is involved in SDMX since the first. In 2005, participated in various projects in SDMX. He worked as an international SDMX expert at the OECD, has been responsible for the ISTAT SDMX architecture in OECD CCC community. He started working on VTL in 2015. Now he's a member of the VTL task force. Dario, floor is yours. Thank you.
Thank you, Angelo. Good afternoon, everyone. I'm here to show you this brief presentation, about some simple steps that you can follow in order to implement VTL in your institution. This document was born from an idea of my colleague Laura Vignola, that could be here, but should be online. And we took inspiration from two documents already provided by the statistical working group, the checklist for data provider and data collector. So more or less is the same schema. Okay. First of all, we want to focus our attention on the benefits and the disadvantages that you can encounter in order to, if you want to introduce VTL in your application, in your business process. Some benefit. First of all, the standardization. If you want to start to industrialize your business process, maybe you have to start to use standard. If you want to be able to reproduce your processes and obtain similar results. So the standard, you have to use standard. Is also suggested by the high-level group and the Ignatius group in 2010 to start to use common tools, common processes, common methodologies. And if we use a common language, we can also start to share our documents, our information, and in this case, we can share also the transformation and validation rules. VTL is part of the SDMX initiative, and behind SDMX, there is a large community that can help you during your implementation, trying to solve also your issue. There are a lot of forums, a lot of people that knows VTL and SDMX. There are also some disadvantages, so we found two disadvantages. First of all, VTL can describe really complex validation rules, but have to be learned. And so you have to spend some money to learn VTL. And if you want to introduce VTL into an already existing process, you have to modify that process. So this adds cost to all the process of the implementation. If you agree, if you want to start with VTL, before you have to answer to some question. At what step of the statistical business process you want to introduce VTL? In GSBPM schema, there are a lot of pillars, and VTL can be used in more than one of these pillars, but you can decide to choose one or two. It depends also from the resource and so on. Which kind of rules VTL support validation and transformation. You can decide to use one of them or both. On which process, already existing one or new one. And if there is an external project. For an SCI, for my institute, for example, is really important because if the international process is mandatory, it could be, for example, proposed by the European Commission. It can be a great motivation to start the implementation of VTL. And the last, but not least, maybe we have to move at the beginning, the last line, the management. If your management doesn't agree on VTL, your project will fail. It requires effort from people and also from money if you have already existing business process. Oh, no, sorry. Okay, this is more or less the schema of all the pillars. I don't think that we have time to see all the point. Maybe the first three could be enough. So we have to just I cannot see. Okay, you have to decide where to intervene to act with VTL. In which of the pillar of your PPM you want to insert VTL for validation on transformation, and where is the point you can bring for the maximum benefits. After this, so you create a subset of the GS BPM pillar steps, and if you can apply another filter, deciding which domain you want to analyze, because you can decide to use to implement VTL on all your domain, maybe some specific. It depends also in this case from your resources. The objective. You have to define what you aim to achieve through the use of VTL. Maybe simplify the data cycle. In a lot of organizations, also in our organization, there are a lot of mechanisms to produce validation. Excel, SAS. So maybe with formalized language, and you can unify the validation transformation process and simplify the data life cycle. You can harmonize the rule, reuse the rule. Because if we think that no domain is special, you can use the same rule, validation rule for all your domain. And other goals, maybe you can improve your data collection. You can start data sharing because you can add information in your data. Now you can also send the information related to the validation and transformation. And also data lineage, because with VTL you can describe all the evolution of the data from microdata to macrodata. And also if you want to come back to, so starting from macrodata to can come back to microdata. And one point, we highlighted this box because if you remember that I said to speak with management. Also in this point, it's at the beginning, you have to start to speak with the management, inform of all the changes and all the enhancement of of your project, in order that I can say to fidelize the management and try to complete all the project. Participate to international project. We decide to focus to this specific point, to this specific scenario that, for, as I said, for an SI is very important. And also to say that participating to the meeting is really important because you can understand deeper the project requirements. You can deal with the others to the same issue and try maybe the same solution. You can share solution, and also because the domain more or less are the same, it's not my sentences, it's a high-level group sentence, so no domain is special, and so you can share also operators or the VTL rule set. So that was the needs. Now we have to start to plan and organize our project. First of all, we have to identify the participants, the resources, the people at the beginning. So you have to choose your statistician and your IT staff. And maybe you have encouraged cross-functional collaboration. They have to work together. They have to stay at the same table to get together. And okay, you have to check the knowledge level. You have to, so not all of the people knows VTL, so you have to understand the knowledge level about VTL. If there are tools already available, so if there is already an existing tool that satisfies your needs, maybe you can use that tool. Otherwise, you can plan to design your own customized software. After the evaluation of the resources, you can start to think if you need a training for VTL, but also if you decide to use an external tool. So you can maybe call external trainer that can help you to learn the external tool. The metadata. Now we have the resources, we have more or less the idea on how to work because we have the tool. Now we have to deal with the metadata. We have to choose the data structure. That there are three possible scenarios if the data structure are already present in your institution. If they are provided from an external organization, in our case, for example, from Eurostat, or if you want to start a new survey and a new domain, so you have to create a new data structure. You have to identify the metadata, all the metadata linked to the data structure. So you have to identify the value domain, Okay. Un po' l'aggiusto. Okay. All the value domain linked to the components. In this phase, you can start to think if database based on the VTL information model is the best solution. Also, in the previous presentation, it was shown that VTL information model and VTL and SD mix information model are similar but are not the same. So there are some advantages to convert the SD mix data structure into a VTL data structure. Not all the components can be mapped directly, especially with the 2.1 version. In the case of multi-measure, maybe you have to perform a real mapping that cannot be done at real time without a human interaction. Okay, there we define the input, the output. You have to clearly outline the outputs that should be disseminated, and start to think about the rule. You have to think about the validation and transformation rule, and if all the rules cover all the aspects of the step of the GSC BPM that you want to cover with VTL. Also in this case, if you are part of an international project, you can share experiences and solutions. These are more or less all the validation, the rules that we have to define for data collection, microdata validation, in which you can reuse some validation rules used in the data collection. In the first case, you usually use rules on each record. We call intra-record validation rule. In the same microdata validation, you can aggregate also the rules. Use the same, but with aggregate record. And depends also on the level of validation that you want to apply. And so I highlighted the word reuse. When you deal with transformed and aggregated data, also in this case, you can reuse some validation rule created for the microdata validation, maybe using some aggregation operators like hierarchical rule set. With hierarchical rule set, you can create a set of simple validation rule and launch this hierarchical operator, hierarchical rule set on a data set. If you need, you can define some other specific rules. You need some rules for output validation. In our case, for example, they are provided by Eurostat, also in natural language. And if you want, you create a new data set, because the result of a VTL statement is a data set. And when you create a data set, sometimes you can create also a new data structure with new variables. So when you perform a VTL statement, you obtain new object, new artifact. So if you want, you can do also, you can create also this rule. That's a rule. the database. So we have at this point, we want to decide if we need a specific database to store rule set, transformation, input and output. So data and metadata. You can decide if put everything together. It's not our recommendation. For us, it's better to centralize the metadata and maybe decentralize the data. And maybe you can use a virtualization layer. In this case, you have to decide how to store the structural metadata into a VTL database. This is our based on our experience. When we developed the VTL Listat framework, we decided to use a VTL database based on a VTL information model. Otherwise, we have to define some mappings. If you have a proprietary schema, you have to perform a mapping to map your data into an VTL information model. But also if you have a SDMix schema, because I said before, not all the SDMix artifacts can immediately convert it to the information model, especially with the multiple measure. So you have to create a mapping, and it cannot be done at runtime while you are in the same time you are executing the rule set, the rules. So you need this type of mapping. And instead, for the data, VTL doesn't work with the data at the end. Its focus is on the metadata. Yes, at the end you have to execute the validation transformation rules on the data, but you cannot do with VTL. You need a compiler, an interpreter, a software that convert VTL into an executable language. So that is something that concerns your RDBMS, where your data are stored. But for VTL, it is not important where are the data at this moment. When you translate and when you execute, okay, we can be interested to the data. If you decide to design your software, we had some suggestion. The user interface implementation, an intuitive and user-friendly interface. As I said at the beginning, VTL requires a certain amount of effort to be learned. So if you can, maybe you can provide some mechanism to help the statistician to write rules. For example, autocomplete, the suggestion of the operator, templates for the really complex operator, like the hierarchical rule set. And also a metadata handling could be useful, in which the statistician, who is writing the rule, can immediately check if the structural metadata is present on the database. It maybe can drag or drop the definition of the metadata into the rules. So we need a module to create, editing, and deleting VTL rules. Once, solo 5? Okay. Once you completed the phase of writing the rules, you have to convert them, to analyze them with a syntactic and semantic validation. You can use the ABNF provided by the VTL task force. And if everything is correct, you have to convert these VTL rules. To compile, to interpret, there are a lot of, also in the previous presentation, a lot of tools to perform this operation. And after that you have an executable language or a software that works on the data, you can execute your validation rule and obtain the results that can be disseminated. And if you want, you can also think to implement a security model for user authentication and authorization. Okay, I have only 5 minutes, but this is, so we planned, now we have to build this, so it is really, we can go quickly on this phase, because at this point you have to create everything. You have to aggregate all the building blocks, create the workflow. So you can choose, but it depends on your policy and on your institute, the database. You can decide if you centralize the metadata in the data. I suggest, I said before, to centralize the metadata and decentralize the data. You can implement the database, the tables, and so on. You can aggregate everything, and at this point, we have all the infrastructure. We can create, we can write our rules, execute them onto the database, validate the output, and conduct through testing of the rules for accuracy and effectiveness. Dissemination. Now we have the new data, the new values, the result of the transformation and validation. We can disseminate them, for example, through secure channel. For an NSI, for example, could be dummies. You can select an appropriate dissemination, for example, SDMix. And as maintenance and support, you can establish a process for maintaining and upgrade metadata and rules. So the last slide, evaluation and lesson learned. So you can check if you reached your objective, if your project stayed within the defined scope, if there is any deviation from the initial project. If you evaluate how well the project adhered to the allocated budget and effectively managed the resource. So it's quite important. The quality of the deliverables, and at the end, analyze the lesson learned through the project and how those insights can be applied to future projects. I hope to be on time. So.
Thank you, Dario, for providing a checklist for a VTL project, which is quite new, and then quite interesting, the mapping with the GSBPM. That's very, very nice. Well, up to now, we have the 4 institutions that have experience with VTL. Banca d'Italia, Meaningful Data, BIS, and Making Sense, and ISTAT. And now we are going to have a presentation by a sniffing company. We just evaluating the possibility to use VTL for a very important project. I invite Noah here. Noah Berger is a software developer and architect as a director in data statistics at Deutsche Bundesbank. He works in the design and implementation of statistical data production pipelines, in the customer reporting of securities and interest rate statistics. Since 2023, he's also a member of the Bundesbank team contributing to the Common Data Management Project, which is the big project that I was talking about. It expected the business users of the integrated reporting framework, IREF. They will design the business validation and transformation rules and are trying to see if VTL can be useful for them. Noah, the floor is yours. Thank you.
Thank you. So let's start directly with a short overview of the contents of the presentation I will give to you today. So we start with a short introduction of the context, and I give you an introduction at the CDM project itself, which stands for Common Data Management, and on the IREF framework, which will be the first use case of the CDM project. Then we will start with the role that VTL will have in the actual CDM and the IREF use case. And the main part of the presentation will be the proof of concepts that we currently conducted for evaluating VTL in the stake of the CDM and the IREF. I will end the presentation with a short summary and outlook. And let's start with the introduction. What is CDM? CDM stands, as I already mentioned, for Common Data Management. And it would be a platform where multiple use cases could be onboarded in the European scope. So it would be used by the actual ESCB and the SSM and will be an end-to-end platform. So it will start by the collection of data and end at the actual insight generation. So it will consist of various components enabling to actually create data pipelines, starting by the actual data collection and ending by the compilation and the data analytics. So in the actual picture here you can see we will onboard different data providers which be part of the actual ECB and the SSM, and the actual core platform will then be developed to actually provide the data to different consumers. One of the main goals is also to provide this equal analytical access to the whole ESCB to actually analyze the data that will be collected by the CDM platform. In the next slide, you can see the main components of the actual CDM platform. So one component will also provide some validation and transformations, and therefore we currently envisage the usage of VTL in the future. That's also why we are currently conducting multiple POCs to actually evaluate if VTL can be used for that purpose. Yeah, let's go on with IWIF. IWIF will be the first CDM use case. And yeah, it is currently the case that we are in the in the US system having 20 countries which are implementing 20 different national specifications and have also therefore 20 different implementations to actually collect the data and provide some actual analytic purposes with it. The integrated reporting framework envisions to actually reduce the reporting burden by integrating the statistical reporting for banks. The goal is to actually define the collection process once, evaluate it once, and collect the data only once, not as it is today. The goal is that CDM and especially IWIF will perform as one system. And already some main steps has been started towards common statistical data collection, which are, for example, the FinWeb Solo alignment, the LDM, which is already developed and currently under evaluation. Yeah, as you can see, IWIF will be the first CDM use case, but the CDM platform itself aims to standardize full data management for the ECB and the SSM. So the goal is to yeah, actually have future use cases also onboarded on the CDM platform, and IWIF will just be the first use case that would be used to onboard on CDM. So CDM itself involves just creating the required architecture for the data management use cases, and IWIF represents the first use case that will be onboarded on that platform. Let's start with the role of VTL in CDM. So the goal of CDM itself is to actually have validations and transformations defined by the business users themselves. So the current business requirements, for example, include the ability to provide validation and transformation rules, which are then developed via business rule language by the actual business users themselves. And then to actually support the business users, we want to also have a convenient IDE with syntax highlighting and autocomplete and also debug features available to actually make sure that yeah, the language can be used easily, and as well trainings to yeah, set up the actual business users, help to build up their knowledge using the actual VTN language, as it still requires some initial yeah, tasks to actually get some knowledge of the VTL language itself. So currently for the business rule language, we are evaluating VTL within CDM, and yeah, actually evaluating it with different POCs that I present in the next slides that are following. The first POC that has been conducted, or the first POC groups, is the development tools to support the actual user activity itself. So to enable business user a comfortable development environment to actually yeah, develop the VTL scripts themselves. So we started with the Trevor's Jupyter kernel that is already available, and with this kernel we built up a simple interactive tutorial which is giving some introduction to the VTL language. It's quite interactive, so I'm just showing a few example slides. So it's providing a nice introduction, showing how actually VTL is envisioned to be used in the CDM platform, why we are using it, providing some high-level overview what language elements are part of the VTL. And then what is quite nice with the actual Jupyter kernel is that we can actually execute some sample statements right inside the Jupyter notebook. So for example, we are showing in the actual notebook how to implement some joins, and the business users then have the opportunity to actually play around directly with the VTL language and gain some insights and knowledge how to use it. So here's, for example, a join operator shown, and a business user can easily integrate some additional functions, play around with it, and actually get some knowledge on how to use the VTL language. The second POC that we already conducted was some syntax highlighting features and auto-completion. So therefore, we provided a single language server, which is following the language server protocol, and also already implemented, and is working quite nice to get a nice user experience for the business users. The next group of POCs we conducted was a comparison of the VTL implementation with the defined standard. As already mentioned, first we played around with the Trivas engine, and that's also why we used Trivas for this first comparison with the standard to see how it is actually fulfilling it currently. And it was a quite nice experience to test the Trivas engine itself. It has a Spark mode and in-memory mode, as already described by Nicolas, and we tested it with a large set of data that has been available by the Banca d'Italia. We found some high-level results, and these include some minor syntactic deviations from the VTL standard, some missing functionalities, and actually the actual sequence of the transformations is currently defined by the order the statements are written in. VTL itself normally has the opportunity to actually calculate the execution order itself from the statements and see how the dependencies between the statements are. We are looking forward that VTL is more standardized in the future, as the VTL task force is currently putting efforts into providing a standardized test set and ensuring a stricter adherence to the VTL standard in the future. But the experience was already quite good, and we really liked the Trivas engine so far. The next POCs that we conducted were some performance assessments to see if VTL, and especially the engines we tested already, can actually are performant enough to actually be used in the CDM and also the IWA framework. We started also here with Treva and used it on the AWS Glue environment, as it is fully managed and serverless and quite easy to scale, and the integration capabilities in our current AWS architecture drafts of CDM are quite good, at least for the investigation phase. The first thing we came up was that the current latest version of Glue is not supporting the latest Java version, therefore we had to downgrade Trevas itself to make it run. But the high-level results of the performance tests here are that the runtime is comparable with the direct execution as the transformations in a PySpark job. So the additional VTL layer is not adding or introducing significant performance disadvantages. We are still working on improving the actual Spark environment that we have been used for testing, as it still cannot fulfill all of our performance requirements we have from CDM and from the IWA framework, but the actual overhead of VTL on top of Spark with this engine is quite small. We as well conducted some performance tests with the meaningful data engine that has already been presented to us. And we use the in-memory mode as it is currently implemented. And it's also a nice experience, as you can get rid of Spark shuffling and the glue provisioning with using this in-memory mode for small data sets. We are benefiting from having all data in memory, and we are maybe envisioning in the future a combination of a Spark engine and an in-memory processing engine to actually benefit from both worlds, or actually get some ideas to scale up the engine for big data sets in another way. The tests have been conducted with anachronic-like validations, which has been already available for the meaningful data engine. And also there, the result is that the additional layer of VTL is not introducing significant performance disadvantages, which is a quite nice benefit out of our view. Yeah, let's go to the summary and the outlook of the POCs we have conducted so far. So we are still going to plan further POCs on the performance requirements, especially as VTL is not fulfilling all of our requirements in the currently used engines. But as already mentioned, the engine itself and the VTL is not introducing so much performance disadvantages. So yeah, especially the POCs will be more on provisioning some better execution environments for the VTL itself. Then we actually plan to expand our contribution on VTL itself when we actually have the final decision that we will be using VTL and one engine in the final version of CTM when we come to the implementation phase, and to improve the actual development tooling that we have currently available. Last but not least, I want to thank everyone that has been involved so far in the POCs, especially the two teams which have been provided, the open source engine and as well the SDMX and especially the VTL task force. Thank you.
Thank you, Noah. This is a very market advertisement campaign for VTL. I invite all the presenters here to the podium, and I open the floor. I'm sorry to have bombed you with all the information, but we have a very rich presentation that you have seen. So now all of we are available for any questions, curiosities, or floor is open. Thank you.
Thank you. It was very interesting to see all the presentations, and in many respects, I see our main use case and next step in our development work reflected. So at the OECD, we have the big plan of moving all our production system into being supported by .stat cores in the background, but we are still trying to find the position of our future calculation engine. And in looking ahead and trying to architect the solution, we have an eye, of course, on VTL as a possible component, and I could recognize ourselves really in the layering of our application, the same way as Banca d'Italia Attilio presented the different layers of the application. I really only missed one component which didn't really come through in any of the presentations, and I would like to ask you about that component, how you see it in your institutions, is the orchestration at a higher level. So just to give you an example, we have something like 100,000 rules established between time series in our short-term economic statistics area, and we orchestrate that with an Excel-like functionality where we recognize all the dependencies. If we touch one series, we know the upstream and downstream dependencies as a whole, and then we execute calculations in a certain sequence. If I understood correctly, VTL does that, but or in your cases, but at a very micro level, at the program level. That is, you don't seem to have an awareness of all the VTL rules that exist in the system. Maybe the transformation schemes presented by Glenn go in that direction, but then, yeah, we will need to have powerful tools around it to build this kind of larger scale dependencies in the system.
I am a mathematician, and I used to learn that a lot of exercises, very difficult ones, when this is left to the reader for yes, VTL voluntary is not going to put everything in one place, so there are some pieces missing. In the last VTL task force meeting, I just gave my experience of Banca d'Italia just because we started a lot of, and there are some pieces that which is the determination. There are input-output driven transformation and so on. That piece is left out, so we can. Banca d'Italia, but also other experience can help you in how to put all these things together, because the VTL just build the direct aggregate graph based on the dependencies, but these dependencies should be calculated before. So that's something that we can, me, Attilio, or the one for VTL task force, just contact us. And this is the missing point, the missing part of the VTL, which is a little bit how to put VTL in production, in a production process. This is left to the reader. And so please, you have my contact or whatever, and so please free to contact us. Thank you. Abdullah and then Luca.
My question is going to be a bit long, so please bear with me. So I'm just thinking about a typical, simplified but typical data life cycle at an international organization. I'll take the example of UNSD, and you could say that about, let's say, our demographic statistics or energy statistics or pretty much any other subject matter domain. So a simplified version is this. We receive Excel questionnaires from the countries. Why Excel? It's because this is the lowest common denominator, and it's probably for quite a while we're going to rely on Excel as our primary data collection mechanism. This is basically, if we move away from Excel, our response rates will drop. That's why we have to use it. Anyway, we receive Excel from the countries. We do consistency checks, we retrieve the data, and from an Excel questionnaire, put it into a database. In the database, we run content validation, and if the data is inconsistent in the questionnaire, or if there are content errors in the database, we'll contact the countries and try to get an update. So once the content, validation has run, and the consistency and coherence has been established, we run some aggregations on the data. Regional aggregation, it could be derivative indicators, whatever. That you obtain the final result. That final result probably will run another round of content validation. And then if everything is fine, you will pass it on to dissemination. And let's stop there. Of course, dissemination also includes the preparation still of like PDF publications and publishing it online. But that's the simplified view of data lifecycle at UNSD. When I first read about VTL and when I tried to imagine how it's going to work, I was really taken with it, because think about this. At this time, you use tools, SDMX tools, to get data out of an Excel questionnaire. They provide structural validation in the process. You use VTL to run content validation. Then you use VTL to run aggregations and transformations. Then you use VTL, if necessary, to prepare the dataset for dissemination. Then you publish the dataset as SDMX on a platform such as the .stat suite or another. Well, the design of such an information systems, on the average, we did it in-house. And a typical information system would take 2 years or longer to create. My guess is that with VTL and SDMX tools in place, this should take far, far shorter. Because hopefully you won't even need to write a lot of actual execution code. Maybe a little bit Python here and there to move the data along, a little bit maybe SQL. But otherwise, you can rely on the tools and you can rely on scripts such as VTL to perform all of the basic functionality. My question is, and this is for all of you, is how far do you think we are from this scenario? Because VTL has been around for a while. I've been looking forward to it. it's taking longer than I expected. So at this point, how far do you think we are from this? From practically replacing an end-to-end information system with available SDMX tools, VTL tools, and a little bit of plumbing code. Thank you.
Okay, I think that we are close to that. At least for the FMR and VTL communication, and I leave the floor to Attilio, who is conducting, Attilio and also some other colleagues. So to include, the problem is that VTL is not attached directly to SDMX, because, for example, the Traverse engine is also used for DDI. So that's why we are not focused on the SDMX. A lot of work has been done and will be done to put FMR and VTL engine together. And I leave the floor to whoever wants to answer.
I prefer to leave, since we are both from the Bank of Italy. I will add something at the end.
Well, I mean, I think we are there. I mean, when people ask me what is missing to VTL, I always talk about the Spark, not the Apache Spark, not the. But it's this first big institution, because there are already some institutions using it, right? That starts using it and that everybody takes notes and says, okay, this is working and this is a good direction. But nowadays we have different engines, right? So that are fully working and that you can fully implement. So I think technically we are there, and there are different solutions that you can use. Then I think it is more, I mean, as Dario was saying before, it is not easy to take this decision, right? It is a paradigm shift. It's not something that if you decide to go with VTL in production for your validations and for your aggregations, it's not a light decision. It's not something that you should do from today to tomorrow. I would love it to be like that, no? That tomorrow we have more people using VTL, but I know it is not. But I think from a technical perspective, we are there. It is already possible to do that.
Yeah, it was a bit the Angelo diagram with the VTL phase of adoption. It's kind of choice to how to conduct the changement in organization to be able to adopt VTL. But I think so technically we are ready to provide some nice tools and support also. It's not a technical issue, I would say. Even the connection with SDMX, you say we handle DDI in Traverse. Now we build VTL rules from DDI and we execute with. So we can also integrate other things, building plugins you already have, we have a bit. So solution exists. Is mostly a way to organize this switch. And giving also the assurance for customer, for organization that the team is strong through the task force, through the involvement of companies. We are ready to support and to go together.
I agree. I think we are almost there. I think 2.1 will be kind of a cornerstone from this point of view, because we worked hard on the harmonization of the understanding of VTL that until 2.0 was not completely, let's say, done. Mostly because everything was on paper and the engine that were existing in some cases since many years, but had been developed with different use cases, different scenarios, and so they adapted a bit to the scenarios. But now we are, the important thing is that we are on the same page from, let's say, the interpretation of the specifications, and we are enforcing it down from a technical standpoint. So that's the core part, according to me. What is still missing, probably, but it's not something that is missing, it's normal, because we don't have production, a long history of production environment, is what the previous question was asking, actually, it's the orchestration part. How do you organize? Because VTL The specifications just tell you how a transformation has to be done, what is the meaning of a transformation, and from a topological point of view, you arrive at in SDMX, we call it the transformation scheme. So the topological graph and the precedence between the operators and the operations and so on and so forth. But how you load data, how you disseminate your data, how you orchestrate the set of transformations inside the business process is something that is still up to the fantasy and technical knowledge of the people who want to implement it. And soon, I think, we will have patterns for this. And as soon as we have patterns, probably the picture will be complete.
Sorry, if I may add something to that, because I think it is important, and also coming to the first question. I mean, I think that VTL did a lot of good things. The original people working on the VTL, who was not me, they did a lot of good things. One of the best things is the information model that we have discussed several times. It's simple and effective. And another good thing was to leave things for implementation. And VTL does not prescribe anything about that. And for me, it is good. It is an advantage, and it makes all the sense. Right? I think in this case it is good to separate concerns, right? So this is a language with an engine to validate and transform the data, right? This is, okay, it gets along very well with SDMX, right? It's the same people in the end, the same organization doing it, but also on purpose, it is not exclusively for using with SDMX. And I think that's a very good idea as well, because in the use cases I know, for instance, if I see the CDM case of the ACB, they may be using SDMX for some things, and maybe they are using other technologies for other things, right? So it is very nice to be able to have one language, business language, and one engine for the validation and transformation of data. So all this to say that if you want to support several use cases, I think it is good to leave it open. In our case, for instance, what we do is to separate it completely. So we have what I was talking before, this VTL manager, right? So that it is separated. Then how you receive your data, how you store it, it is then your business, because then you can plug it in different places. That's a choice. Of course, I think it would make a lot of sense, right, seeing that there is the .stat suite and there is the FMR, right? So maybe leveraging on that and building something that is purely 100% SDMX, and it is following some things that are already implemented in the existing software, I think it would make sense. But I think that would not be the only use case, right? So I think it is good that this is open to other kind of implementations.
I have a question that is a bit more at a higher level, and I'm a bit afraid of asking it because I'm afraid of opening a can of worms. I mean, it's all very interesting what you. I must say I've been. You know, Abdullah was mentioning it's taken a long time, but I've been really surprised by the new things that came out of a VTL in the past year and a half. I was already surprised in Bahrain. I'm even more surprised about the development in the last year. So that's very good. And besides, let's say, the technical development, you also start having some guidelines. I mean, what Dario presented was very interesting. It's also a sign of things becoming a bit more structured. But when you go on sdmx.org on the website, there isn't much about that. We have a place for SDMX tools, and the only VTL tool that is mentioned there, I think, is the VTL editor by Banca d'Italia. I don't think Trevas is not mentioned. I just checked also. There's nothing about the other tools mentioned. And when it comes to some guidelines, right, that may start coming based on what Dario did, which is also inspired by the checklist for DSD designers, as you mentioned. I'm thinking, okay, well, where would that be hosted, right? Where would you host such a thing on the SDMX website? Is the sdmx.org website the right place to host it? Because as you mentioned as well, VTL was built in the SDMX community, but is not only necessarily for SDMX. But I think it's something to think about once it becomes more mature in terms of disseminating a bit better the information, showing what is available. So I would like to have the view of, well, anyone who has a view on this, on how you see this being better disseminated.
I remember a discussion when I just entered the TWG and the VTL task force, and Edgardo was heading the TWG. Is VTL going to stay in the SDM, under the SDMX umbrella? And the VTL task force is one task force of the technical working group, or just another technical working group devoted to VTL? And the discussion is still there. We see a lot of advantages being under the SDMX umbrella. Also, the funding of the new documentation was just thanks to the sponsor who funded this initiative. So that's just to say one thing, but it's not the most important one. We have to progress for the communication. You are perfectly right. So the SDMX pages about VTL are dead, really, are not updated that much. So we have to do something on the communication, not marketing, but just communication. And we will see how. We are now focused on the real things, and then probably when things are mature enough to be market, we will update. Surely it will be under SDMX as it is, and thanks to the sponsor for their help. And surely we have to do something in the communication, that's for sure. And also on the training, all the training, because we know very if someone, also in Banca d'Italia, it's there from 2008, when they see an VTL or XML expression, they say, what is this? So, and probably also the lesson learned by the generative AI and so on can help in this. So probably in 1 year time, we have finished this time, so probably we'll do something also on the communication and training side. But thank you for the suggestion.
SDMX.io is also a good way to promote VTL with webinar article. I don't know, but it's also a good support. Good.
Maybe just 3 points to add to this here. I remember a few years ago we had a discussion whether we actually want to make VTL an ISO standard as well. Now, seeing the curve, going down, going up again, and seeing all the excellent use cases and implementations, I think it's really worth to think about this again. And I know in the past the ECB was pushing this quite a bit, but then we had some discussions in the Secretariat where we said maybe it's not yet so mature and so on. So food for thought, whether we should put this on the Secretariat agenda, and maybe some of you have a comment. Especially maybe what I would like to know is, do you see any added value in your current work if it's really a certified ISO standard? That's the first thing. The second thing, so I fully agree with Luca, I think you need to be much better in the marketing. And it's not just adding the tools to the site. It's actually creating a business case, creating a roadmap, maybe 2030, as we do for SDMX. We are currently revamping the sdmx.org website. So you should definitely very soon get in contact with our designers to also see how VTL fits into the new navigation. And there's some time criticality here, so I would suggest in the next 2 or 3 weeks. And then the third thing is, yes, sdmx.io. I think it's not just about learning courses, e-learning, etc., but it's really about presenting the use cases here. And I think we have a lot of really excellent presentations today, and we have good use cases, and I think you should flesh them out and put them on sdmx.io so that people better understand how they can actually use VTL. And then something which is completely crazy, I know there is DPM in the CDM platform. There's VTL, SDMX. I'm a strong advocate to merge all these things together. I'm very open with this. Yeah, I've also mentioned this to some of the ECB senior management already. I think my vision is that at one point it's not SDMX.org, but we have SDMX, DPM, and VTL. Yeah, so that we have basically a common standard or a joint platform where we present those standards. But again, that's as a chair of the Secretariat, my long-term vision. Let's see, maybe in a few years we can materialize this. Thank you.
If I may say something very quick, sorry. I can certainly say I'm not very good at marketing, and I don't know exactly what is the best thing to do. Well, or maybe I can. We have done the exercise of translating some validations, existing validations. I always say that the thing with VTL is that the starting point from the institutions, sorry, allow me to say it, is very bad, right? You start seeing Excel files where you have a time series per column and then an operator, and I mean, in the end you understand it, but it's not the best way to share or to maintain, right? So we have done the exercise sometimes of translating this to VTL, to making sure that it works and sharing, and the best use case would be that these things are shared. I mean that actively the organizations, when it exists and it is tested that it is fine, they share this, because this is actually the idea, right? So if the BIS, for instance, publish the validations in VTL, it's not only that you can use the engine to validate, is that for all the rest, they know what to validate and they can use another VTL engine or the same VTL engine to validate. So I think that would be a good start for getting more traction with VTL, sharing VTL script codes from the higher level institutions.
I agree that the sponsors from this point of view could help much, because like with the SDMX IO initiative, it could be a place for training material, for demos, also for some online places where users can experiment himself, maybe in a guided way. We have many technologies that could help from this point of view, and convincing people is, for the most part, in these cases, showing how it is. No need for particular marketing. I think we are at a point where the language is stable, it's not complex. If you start from an SDMX starting point, you also understand most of the concepts immediately. And this is, let's say, a matter of finding a way of doing it. As Angelo said, we have been focusing on the core parts now, because the language had to be refined in a way. I think that the API, if we succeed in creating an API, a REST API, will help even more, because it will give the possibility to use different engines from the same orchestrator. That was one of the things, and enforce the standardization of what you are doing, because you could switch engine seeing that things go exactly the same way. So this is an important step that is going to be done. And this is something that has VTL in the last years has grown up from the base. I think that if you recognize that now the standard is mature, the work that has been done is valid, it is the time to give it a chance to fly, let's say. For the CDM, for example, I think that there was a time when they were deciding if using VTL or not, and comparing it to other languages like R, like SQL, and so on. So we were engaged for a webinar trying to explain the pros and cons of VTL and a comparison with other languages. And we didn't do anything else than get some transformations that today are in SQL, I think I remember. We just translated them. We explained how VTL worked, and we showed how they would be done in a VTL engine. Now the choice, the temporary choice has been done in that direction. I like to think that even that webinar gave its small contribution, but it was not anything else than showing how VTL works in practice. Nothing. So what we have to do is find places where it can be shown, maybe even in a self-service way, by the users that are interested. And I agree that today we do not have these places, actually.
Yes.
Yeah.
If I may.
No.
If I may only, just if I can. Just a short comment. As you can see today, I remember when we were presenting on the global conference in Bahrain, we had only one presentation on VTL. Today we have with us the ECB, with the CDM project. We have also the BIS using and trying to find use cases inside by using VTL language and how to connect it to the SDMX. So I would like to encourage you to try it. And we have making a great effort in order to be easier for the technical users, but also for the statisticians in order to evolve and to try the language. So give it a try. Try to find more use cases that may fit into your organization, and let us know if you need any help.
Luca, do we have time for one question? No.
Otherwise, all of this is your package.
Well, it has a little bit to do with Luca. No, there's a lot of history in validation, I know, and Luca knows because we were both in a lot of validation projects, and that's really on the statistical side, the official statistics side. And now it seems like VTL is gaining some popularity in the banking side, and we have INSEE supporting the Traverse. I don't know how exactly. Traverse is on my awesome list because it's open source, and ISTAT is for a long time involved in VTL, I know. So the tiny remark I wanted to make was from these previous validation projects, I remember discussions about all the rules that are around on data reporting from statistical officers to Eurostat or other international organizations, but especially to Eurostat. And there has been inventory of all these rules, and this is really a lot of rules, and they are very, very complex for a lot of statistics. And they were aggregated in the so-called, if I remember well, Luca, most common rules by Vincent Tronin. And yeah. So, and this is maybe worthwhile to have a look at it still, because if you have a kind of a easy mapping of your implementations or templates or whatever to the most common rules that are in the ESS used, then it would be even an opportunity, a good use case. So that was my thought.
Just give the math and yes, we did with Anacredit. There were 1,000 or something, more or less, for Anacredit. So
something with 1,000.
So please, thank you.
Olaf mentions this document, which was indeed produced. It was never, however, officially published for different reasons. But if you think it could be interesting, I will send it to the task force, the latest version available.
Yes, another use case. So.
Yeah. Yes, that exists.
I mean, that would be a rich collection of a lot of rules.
Maybe the validation handbook for national accounts maybe is not as tightly organized as it could be, but yes, that's also a rich use case collection, yes.
I saw a hand by Jens. I don't know if we have time, Luca. You are the owner.
It would be better to close it.
Okay, thank you so much for your interest.